In our next section, we're going to look at the basic configuration examples of OTV and specifically look at the details of what's going on in the control plane behind the scenes. And then once we know what are the general requirements of establishing the tunnel, we'll start to get into some more complicated designs of where we have the sites that are multiple hops away in terms of the layer 3 network. We'll talk about how that affects the underlying transport requirements of both layer 3 unicast and layer 3 multicast routing, and then talk about the advanced features of OTV beyond that. But as I talked about up to this point, the main requirements to begin with are going to be that we have layer 3 unicast routing and layer 3 multicast routing reachability between the sites. Okay, within an individual site, when we have two or more edge boxes that are tunneling OTV, which are then called the authoritative edge devices, those boxes will need not only IP reachability to each other, like to be able to ping, but they'll also need a regular layer 2 classical Ethernet transport, okay, like a layer 2 trunk link between the boxes. Okay, we'll come back in later examples and talk about how we can remove the requirement for multicast, which is going to be with the adjacency server. But in this example, we're going to have the edge devices essentially directly connected. So it's going to imply that they have layer 2 connectivity, they have layer 3 connectivity, both for unicast and for multicast reachability. Okay, so before we get into the specifics of the config, let's take a look at the topology. And what we're going to be doing is to try to bridge traffic, hopefully not trying, hopefully accomplishing, right? Bridging the traffic between server 1 and server 2. And I have these guys configured with the IP addresses 11.00.11/24 and 11.00.12/24. So these servers are going to have regular classical Ethernet links that are going up to the 5Ks. So we're going to 5K1 and 5K2 respectively. These boxes are then going to have regular layer 2 trunk links that are going up to the 7Ks. Okay, so this is going to be just regular layer 2 traffic, no special config, just classical Ethernet. And then once we get up to the 7Ks, we're going to encapsulate that into layer 3. Okay, so we're going to be doing layer 3 IP on the interfaces of the 7Ks that are going towards 7K3. So from 7K1, 7K2, this is where we're going to be running the OTV tunnel. And then we're going to route the traffic up to this guy in the middle, up to 7K3. And then it's going to be doing just regular layer 2 bridging between its interfaces. Okay, the reason that I'm going to be doing it this way in this particular example is so that we can capture the packets in the data plane and then see specifically what's going on behind the scenes in the ISIS negotiation and then the actual encapsulation of the packets, like the pings that are going across OTV. So the only thing that I have set up to begin with is just the IP addressing on the servers, and then on 7K3, as it's receiving packets in on these interfaces, I have it configured to do an ER span. It's spanning the traffic over to 5K3, and then a 5K3 is dropping off the captured packets over on server 3. This is where we're going to be running Wireshark to look at our encapsulation, to look at our packet captures behind the scenes. Okay, so to start with, let's take a look at on 7K1 and 7K2. The only relevant config I have up to this point is just an IP address at the port level. Okay, specifically, these are going to be 1.1.1.71 and 1.1.1.72. Okay, this is where we're trying to run the tunnel between them. If we go over to server 3, we should see that it is capturing these frames. Okay, so we see the pings that are going between the two 7Ks. And right now, this is encapsulated just over regular classical Ethernet. Okay, so we're not doing any OTV tunneling, it's just regular IP over Ethernet bridging.